Welcome to day 2 of lesson 3-5. Today we're going to do examples 5 through 8 on the back page of our notes that we started on the previous day. So if we remember, glancing back to the first page of our notes from yesterday, we talked about the steps for solving equations. Again, step 1 was to distribute. Step 2 is to simplify and combine like terms. Step 3 was to move the variables to one side of the equal sign, and then step 4 and 5, undo the order of operations, undo addition and subtraction, and undo multiplication or division. So we see in our first example today that we have parentheses, we have those grouping symbols. Therefore, our first step must be to get rid of the parentheses. We must distribute to get rid of parentheses. So, this first problem would then become 2w minus 2 plus 4 equals 4w plus 4. Now that we've distributed, it's now time to do step 2, which is to combine like terms. What that means is, on the left side of the equal sign, negative 2 plus 4 are like terms. So before I move anything, I need to combine those. Negative 2 plus 4 is positive 2. Recopy the rest of the problem. At this point, it looks just like what we did yesterday. We now begin moving our variables to one side. We can move the 2w, or we can move the 4w. It's your choice. It doesn't matter which one you do first. Let's move the 2w. So think about, would you add 2w to both sides, or would you subtract 2w from both sides? In order to make that 2w disappear or go away, or in other words, cancel out, you must subtract 2w, because 2w minus 2w is 0. So in the black, that's subtracting 2w from the left, and here is subtracting 2w from the right. That leaves you with positive 2 equals 4w minus 2w is 2w. And then we write plus 4. Again, we're trying to solve for w. We want to get the w alone. Our options are get rid of the 2 that's being multiplied, or get rid of the 4 that's being added. We know in undoing the order of operations, we save the undoing of the multiplication and division for very last. So we're forced to get rid of the 4. The opposite of adding 4 is to subtract 4. On the left side now, 2 minus 4 is negative 2 equals 2w. And lastly, solve for w. Divide both sides by 2. Negative 2 divided by 2 would be negative 1. W is equal to negative 1. No matter which way you write it, it means the same thing. Now, this was a little bit longer of a problem, but it's still pretty easy, and it's still some basic steps overall. Remember, our first step was to distribute. Let's go through the same steps again on number 6. Distribute the 4. 4 times 2r is 8r. Minus 4 times 8 would be 32. Next, we have a 1/7 to distribute. We need to do 1/7 times 49r. Remember our little mental trick about multiplying by a fraction whose numerator is 1? It's the same thing as dividing by that denominator. So really, we can think about this as 49 divided by 7. 49 divided by 7 is 6. So in other words, 1/7 times 49r is 6r. And very similarly, we can think of 1/7 times 70 as 70 divided by 7, which is positive 10. Now let's see if we can combine like terms. On the left side, 8r minus 32 are not like terms. On the right side, 6r plus 10 are not like terms. They cannot be combined. So now it's time to move our variables. We could choose to move the 8r or move the 6r. Let's move the 6r. To move the 6r to the left side, we would subtract 6r from both sides. 8r minus 6r would be 2r. So on the left now is 2r minus 32 equals, what's left on the right side is positive 10. Get rid of the 32 next. The opposite of subtracting 32 is add 32 to the left and add 32 to the right. That results in 2r equals 42. And lastly, to get rid of that 2, the 2 is being multiplied. The opposite of multiplying by 2 would be divide by 2. For a final answer of r equals 21. Two more problems left. Number 7 looks a little different from the previous two problems. Remember, those are not fraction bars. Some people would say they're fraction bars, actually, but we can think of them as division bars as well. In the case like this, we must remember that fraction bar, division bar, no matter what you say, is really indicating grouping symbols. We're really indicating parentheses there. So, to solve a problem like this, we need to do something I know you've heard about, and that's cross multiply. That means we're going to take these diagonals and we're going to multiply them. That would be 3 times the quantity, a minus 8, and the equal sign. And multiply the other diagonal equals 12 times the quantity, 2a plus 5. So now we don't have a fraction anymore. We don't have that division bar anymore. So it's just a simple distribute. Let's distribute and see what happens. First, distribute the 3. 3 times a minus 3 times 8 equals, then distribute your 12 through the parentheses. 12 times 2a is 24a, and 12 times 5 would be 60. At this point, we need to combine our like terms, but we cannot do that on either the left or the right. 3a minus 24 cannot be combined, nor can 24a plus 60. So we must move our variables. I'd suggest moving the 3a. The reason why I suggest moving the 3a to the opposite side is because when I move that 3a, I have to subtract it from both sides. 24a minus 3a is going to give me a positive number. If I had done the opposite, if I would have subtracted 24a from both sides, then that would result in a negative number. Sometimes we just want to avoid that negative, and that's okay. For some people, it seems a little easier when they do it that way. So continuing on, what is left on the left-hand side is a minus sign in front of the 24. So remember that minus sign gets copied down in front of that 24 also. Therefore, when we read this problem, now we would read it as negative 24 equals 24a minus 3a is 21a plus 60. Let's move our 60 to the other side. The opposite of adding 60 would be to subtract 60. Negative 24 minus 60 is negative 84. So we get negative 84 equals 21 times a. And our last step would be to divide both sides by 21. Let's see if that gives us a whole number. Negative 84 divided by 21 is negative 4. Negative 4 equals A, or you may write it, A equals negative 4. And actually, it's more typical of us to write A equals negative 4. In our very last problem, there's a lot going on. We've got several distributing parts, I guess you could say. So, as with order of operations, we're working with the innermost set of parentheses first. That means, in this case, we need to distribute the 3. So let's recopy everything. But distributing to get rid of that innermost set of parentheses. 3 times y minus 3 times 1 is 3 equals 22. Now, inside those brackets, we have some like terms. Our like terms inside those brackets are 2 and minus 3. So let's combine those like terms. I'm going to recopy my 3y. 2 minus 3 is negative 1. We can no longer combine any like terms inside of the grouping symbols. We cannot do 3y minus 1. They are not like terms. So our hands are tied. We must distribute to get rid of those grouping symbols. 2 times 3y is 6y minus 2 times 1 equals 22. Now this looks very easy. Our choices are get rid of the 6 or get rid of the 2. We know we must get rid of the 2 first because it's being subtracted. The opposite of subtracting 2 is to add 2 to both sides. That gives us 6y equals 24. And then our last step, to get rid of the 6, undo that multiplication by dividing both sides by 6. For a final answer of y is equal to 24 divided by 6, which is positive 4. So now these problems haven't been that bad. I think you would all agree with me in saying that they require a lot of work. And it is very important to show your work. Please don't skip a step. Please don't do 2 or 3 steps in one step. Show every step individually. Take your time and think through each step carefully. Good luck to you, and tomorrow, day 3, we'll look at the last page of our notes. That includes special cases and a little bit more of a review for solving multi-step equations with variables on each side.